In this problem, we're going to look at graph functions using compressions and stretches. And they say the graph of y equals f of x is shown in blue. It's not in blue. And also we have some pink dots here. We're going to need to ignore those pink dots. That's just some bleeding from a previous problem. So the graph of y equals f of x is shown in blue. Draw the graph of y equals f of 2x shown in red. So they want us to basically take y equals f of 2x, and they want us to graph this on this coordinate plane. So the first thing we need to do is identify what they want us to change. And you can see that we have this 2 being multiplied times x. When you take 2 times x, what you're doing is you are horizontally, because anytime you do something directly to the input value, it's a horizontal change. This is a horizontal, this would be a horizontal stretch. Scratch that. That's a horizontal compression. This would be a horizontal compression. Because anytime the value is greater than 1 inside here, we're basically multiplying this x value by 2, 3, 4, something that's larger. So we're increasing the x value, which is going to increase the y value, which is going to pinch the graph in, and my y value should essentially sort of raise over time. But this is a horizontal compression. So what we want to do is we want to take each of these coordinates that we've got here, and if we're horizontally compressing it, what that means is we're changing the x values for each of these. So I'm going to write the original coordinates here. And the original coordinates would be 0, 0, 1, 3, 2, 2, 3, 5, 4, 1, and 5, 0. And if I'm horizontally compressing, and it's a horizontal compression, we're going to say by a factor of 2. If I'm horizontally compressing by a factor of 2, what happens is I'm essentially dividing the x value by 2. So anytime you see a 2 in front of this x, you know it's a horizontal compression, and that 2, basically you need to think of the reciprocal. And you need to take the reciprocal and multiply it by the x values. So for my new coordinates, because it's a compression, so I'm shrinking those x values down, I need to say that this is 0 times 1/2, comma 0. This is 1 times 1/2, comma 0. This is 2 times 1/2, comma 2. Oh, I shouldn't have said comma 0. This is comma 3. This is 3 times 1/2, comma 5. 4 times 1/2, comma 1. And then 5 times 1/2, comma 0. So again, we got a horizontal compression, so we need to, and we're doing it by a factor of 2, so we're dividing each of these by 2. So when I go to plot these, that's not 0, 0 anymore, that's actually, that is 0, 0. So we're going to plot 0, 0 here in green. And then this is 0.5, comma 3. So we're going to go to 0.5, comma 3, which would be right here. So you can see we just moved that point halfway this direction. This is 1, comma 2. 2 times 1/2 is 1. So 1, comma 2 would be right here. And you can see we're cutting this coordinate in half. We're compressing it horizontally. And then this is 3 times 1/2. So that's 1.5, comma 5. We go to 1.5. We go up to 5. And again, we're cutting this point in half. So we're shrinking it down closer to the y-axis. And then we got 4 times 1/2, which is 2, comma 1. 2, comma 1. Again, look at that coordinate. we basically cut it in half. And then 5 comma a half is 2.5 comma 0. Not 5 comma a half. 5 times a half is 2.5 comma 0. So 2.5 comma 0 is right here. And again, we took that coordinate and we cut it in half. So we compressed it by a factor of 2 this direction. So let's go ahead and draw and connect the lines. And it should look like this. So it looks virtually the same, it's just been compressed downwards.